7.5 says a straight line G parallel to AE cuts F at -3 and -9 and R. Calculate the x coordinate of R. So we are told that there is now another line which is parallel to the line AE. Could look something like this. And we are told about one of the points of intersection, which is K, like so. K is -3 and -9. But we are also told, of course, since it's a straight line, we can assume there to be another intersection. We can name that R. Our job is to find the x coordinate at R. So, what do we know about this new line that we've just drawn? We are told that it is parallel to AE. So it means that the gradient of this new line will be equal to the gradient of the line AE, because lines with a similar gradient, lines that are parallel have similar gradients. And in this case, that gradient is 1/4. Then, if we want to get the coordinate or the x coordinate at R, it's important that we understand what happens at R. At R, we have an intersection of two graphs of F and G. And whenever we want to find the coordinates of intersection, or when we want to find the x values when two graphs intersect, we look for when the y values are similar, meaning we are trying to find the x values for which f of x will be equal to g of x, which is the line that we've just drawn here. But we still then need to find its formula. So how do we then find the formula for the straight line in terms of y is equals to mx plus c? Well, we already know one coordinate that's on that line, which is k, and we also know the gradient. So here you can use this formula by substituting into y as -9 and the gradient as 1/4. We can find and substitute into x with -3 as well. We can find and solve for c. So c in this case will be equal to -33/4. If you were to take this to the other side, you would get -33/4. Therefore, your final equation can be written as g of x, which is our straight line, is equals to y, which is 1/4, since that's the gradient, x minus 33/4. Something like that. Now we come back to this. We now need to equate our two graphs together. So equating f and g. F was x squared minus 2x minus 24. That will now be equal to 1/4x minus 33/4. Now we need to solve this algebraically, and the first step is to get rid of the fractions. Whenever you work with an equation, you never want to work with fractions. So in order to remove these fractions, we're going to multiply through by 4. Multiplying this by 4 gives us 4x squared. This will give us minus 8x. Multiplying this by 4 will give us minus 96. And this will just be now x, and this will just be 33. Then we can take x to the other side, it will become negative. So we're going to have minus 8x minus x. That will give us minus 9x. Then taking minus 33 to this side, we're going to have minus 96 plus 33, which gives us minus 63. Then again, at this point, it's best to use the quadratic formula. So you use x is equals to negative b plus minus b squared minus 4ac all over 2a. And again, this is your a, this is your b, and that is your c. So putting these values in, we have minus -9 plus minus -9 squared minus 4. A is 4, C is minus 63, like that. And then we say all over 2A, which is 4. And then from this you'll get two values. One of them will be 21 over 4, or x will be equal to -3. So we get two answers out of this problem, but we can see one of them, because what we are solving for is just the intersection of these two lines, and whenever a straight line and a parabola meet, we can have a maximum of two intersections. So in this case, -3 has already been given. That's the x coordinate for k. So our answer is going to be 21 over 4. So the answer that we don't want, we can put a line through it, or we can say non-applicable. So the x value will then be x is equals to 21 over 4. And that's how you'd solve that question.